Hi, my name is Shirsavar, and in this short video we are going to talk about how you set up a Siglent SSA series of spectrum analyzers in order to measure the conducted emissions of your product as part of your EMC test. Okay, so let's turn on our spectrum analyzer. This is a Siglent SSA series spectrum analyzer which goes up to 2.1 gigahertz. You just have to wait for it to crank up. We are going to set everything up in order to measure the conducted emissions as part of European Union's EMC directive. So there we go. We set up now. On turn on, at least this one is set to 1 gigahertz. So the first thing that we need to do is to set the frequency. Now, the frequency that we would like to measure for the EMC test is from 150 kilohertz to 30 megahertz. So first thing that you do, you press the frequency button right here, and then you can see that these soft menus change, and here you've got a start frequency and you've got a stop frequency. So I set the start frequency to 150 kilohertz. So you first press this start frequency button, you can see that it goes blue, and then you type in 150. You see that the menu has changed to the units, so change that to kilohertz. So now your start frequency is 150 kilohertz. The stop frequency for the test is 30 megahertz. So again, you press the stop frequency right here. You can see that this changes to blue, and you type in 30 megahertz. Now, this is showing now the full spectrum as part of the EMC directive. So from 150 kilohertz to 30 megahertz of this power supply. Now, you rarely look at the entire range. So typically what you do is you look at the smaller segments of the frequency range. So I change it from, let's say, 150 kilohertz and I go to the stop frequency of, let's say, 2 megahertz, and then you can clearly see that you have got these peaks. So first we set our frequency, then you press the amplitude button, and you need to change a few things for the amplitude button under the amplitude menu. First of all, you need to change the units from dBms, which is the default at turn on, to dB microvolt, which is defined in the standard, or if you're working in microamps or microvolts or whatever it is that you're using, the standard is defined as dB microvolts. So I've changed the units to dB microvolts, and you can see that here on the y-axis the units have changed. Then please note that further down here you've got something called reference offset. Now, the vast majority of listens have got a 10 dB attenuator in them, and therefore we need to set that. If you are using a listen that has got a 10 dB attenuator, if you here type in 10 dBs, again you press the dB button, then it will display the axis correctly. So what you measure is actually correct, taking into account that you have got a 10 dB attenuator. After that, you press the bandwidth button. You've got here BW for bandwidth. Now, again, at turn on, the type of filter that is using is not the EMI filter. You need to use the EMI filter, so you press that EMI filter. So that is now set up the way that it should be done in a pre-compliance test, but you can see here that the resolution bandwidth, RBW, is set to 120 kilohertz. Now, the standard that we're going to use specifies 9 kilohertz, so you change that 120 to 9 kilohertz, and you immediately see that it changes the characteristics of the resolution bandwidth so that you see the spikes correctly. Finally, let's change the frequency back to 30 megahertz. Frequency, stop frequency, 30 megahertz. That's the entire spectrum. As I said earlier, you all usually look at segments, but it will be nice to set this preset button so that every time you set the preset, it goes immediately into this setup, so that you don't have to go through all of these steps every time. And in order to do that, you go to File, and you change the save type to STA. I think it is for stands for state, I'm not sure. And then you press the file button instead of directory, and then you say save the STA, and it gives you a window whereby you type in your name that you want. You can name it whatever you want. Let's just stick with whatever it is, STA2. You press enter, and that is now saved on the internal memory. The next thing that you need to do is you need to set this preset button to open the STA2.sta file, and that way it will immediately go into your conducted emissions setup. And in order to do that, you need to press the system button right here. And on the system button here, you've got power on and preset. So you press the power and preset, and you'll see that at power on, it will go to whatever is defined, but at preset, you change that to user. You can go to def, last, or user. So you go to user, and then finally you press user configuration, and it goes back to the files that you just saved. So you can see here I've got STA2, and then if you basically all you do is you scroll down to STA2 and you press the enter, and then every time you press this button it will automatically go to the setup that you have just saved, which in our case was the conducted emission setup. So let's go back. If you see I press the preset button, it goes back immediately to my 30 megahertz range. I want to look at the smaller one, and therefore I can change the frequency. There we go. That's how we set up the Siglent spectrum analyzer. Many of the other spectrum analyzers are similar in the way that they are set up. Thank you very much for listening, and please visit our website for the latest workshops that we run for EMC filter design.